Okay guys, this is your next question from Cat24, the first lot. Please pause the video and try it once. The sum of all real values of k for which 1 upon 8 raised to k into 1 upon 32768 raised to 1 by 3 is equal to 1 by 8 into 1 upon 32768 raised to 1 by k is. Okay, interesting question. Let's see how we solve this. So the things you're supposed to understand are 8 is nothing but 2 raised to 3 and this 32768, if you factorize it is a power of 2 only. So this is 2 raised to 15. Okay, you can arrive at this by starting with some familiar powers of 2. I generally ask students to memorize up till 2 raised to 12, which is 4096. And 4096 multiplied by 8 would give you this number. So technically 2 raised to 12 into 2 raised to 3 is the given number 32768. So having understood this, the first term can be written as 1 upon 2 raised to 3 the whole raised to k into the next term will be 1 upon 2 raised to 15 the whole raised to 1 by 3 is equal to the next term is 1 upon 8, which is 1 by 2 raised to 3 into the next term is again 1 by 2 raised to 15 raised to 1 by k. Now we are going to use a very significant law of indices. 1 upon a raised to n is simply a raised to minus n. So 1 upon 2 raised to 3 raised to k can be written as 2 raised to minus 3 the whole raised to k into, similarly 1 upon 2 power 15 can be written as 2 power minus 15 the whole raised to 1 by 3 is equal to 1 upon 2 raised to 3 is 2 raised to minus 3 into 1 upon 2 raised to 15 raised to 1 upon k is 2 raised to minus 15 raised to 1 upon k. The next thing we are going to use is another law of indices. A raised to m the whole raised to n is always equal to a raised to m multiplied by n. So the first term, which is 2 raised to minus 3 raised to k, will be 2 raised to minus 3 multiplied by k. So 2 raised to minus 3k into the second term is 2 raised to minus 15 raised to 1 by 3. So 2 raised to minus 15 into 1 by 3 is basically 2 raised to minus 5 is equal to the next term is 2 raised to minus 3 into 2 raised to minus 15 raised to 1 by k is 2 raised to minus 15 into 1 by k. So it is 2 raised to minus 15 by k. One last properties of indices at play, a raised to m into a raised to n would be equal to a raised to m plus n. So the left hand side would be 2 raised to minus 3k minus 5. You can also take the minus sign outside, minus of 3k plus 5 is equal to the right hand side would be 2 raised to minus 3 minus 15 by k. You can again take the minus sign outside, it will be 3 plus 15 by k. Whenever the left hand side is equal to right hand side and the bases are same, the powers also have to be the same, right? So next step, we simply equate the powers. Minus of 3k plus 5 should be equal to minus of 3 plus 15 by k. We'll cancel out the minus signs from both sides and write the equation as 3k plus 5 is 3 plus 15 by k. And we are just 2 steps away from getting our answer. We'll multiply throughout by k and take all the terms on the left hand side. We are going to get 3k square plus 5k is equal to 3k plus 15. And now taking all the terms on the left hand side, 3k square plus 2k minus 15 is 0. Now in the next step, many people struggle and try to find out the value of k and then calculate some of the real values of k which are possible. A better way to answer this would be observe that this is a quadratic equation, and for any quadratic equation, sum of the roots is minus b upon a minus the coefficient of x upon the coefficient of x square. So minus 2 upon 3 is sum of the roots of this quadratic equation, and that is nothing but sum of all the possible values of k in this case. And the answer to our question, minus 2 by 3. So that's how we do it. Beautiful question involving a lot of indices and laws of indices. And lastly, the concept that sum of the roots of quadratic is minus b by a. That's how we solve this question.